Here's problem 4015. A photon whose energy is 8 times 10 to the minus 15 joules is scattered off an electron at a 90-degree angle. What is the wavelength of the scattered wave? We know that the difference in the wavelength between the scattered wave and the original wave would be the scattered wavelength minus the original wavelength, and that is equal to the Compton wavelength times 1 minus cosine of the scattering angle. And this Compton wavelength is equal to h over the mass of the electron times c. So that is 6.626 times 10 to the minus 34 over 9.11 times 10 to the minus 31 for the mass of the electron times the speed of light. And that is equal to 2.43 times 10 to the minus 12 meters. This is what we call the Compton wavelength. Alright, well, let's find our incident wavelength. We know that the energy of the photons coming in is equal to Planck's constant times the frequency, which would be Planck's constant times the speed of light over our incident wavelength. Hence, our incident wavelength is going to equal Planck's constant times the speed of light over the energy. That's going to be 6.626 times 10 to the minus 34 times 3 times 10 to the 8 over the energy of 8 times 10 to the minus 15. And that is equal to 2.48 times 10 to the minus 11 meters. Alright, so we have, if we solve for the scattered wavelength, it'd be equal to the incident wavelength plus the Compton wavelength times 1 minus cosine theta. So in this case, that is equal to 2.48 times 10 to the minus 11 plus the Compton wavelength, which is 2.43 times 10 to the minus 12 times 1 minus cosine of 90. Cosine of 90 is 0. So this is going to be 2.48 plus 0.243 comes out to be 2.73 times 10 to the minus 11 meters. So that will be the wavelength of our scattered radiation, 2.73 times 10 to the minus 11 meters.